Hi, this is Phil Hinton. Welcome to another video here on AVForums.tv. Today we have a video podcast and we're at the offices of Panasonic in Bracknell. Okay, Marcus, moving on. I've got another question here from Hodge100 and he says, can you explain 600 Hz subfield processing technology?
Yeah, I can, absolutely. So for talking about 600 Hz, it is necessary to understand that the plasma picture is set up by 12 different subfields per single frame, and if we take as a base 50 Hz source by 12 subfields per each frame, that makes up our 600 Hz. But that's not all about it. It's what we call the addition to it, the Intelligent Frame Creation Pro. That is meaning that we really do a vector detection for moving objects within those subfields and compensate the motion for each single subfields. So that means for a 50 Hz signal, you end up with 600 different subfields per second, each showing a different phase of motion. This is creating, this is helping to achieve our NeoPDPs, the overwhelming motion clarity, the overwhelming motion sharpness, because each subfield carries detailed information of the location of the object, which supports your eyes to precisely localize where a moving object is at that time.
So I mean, the next question there has to be, how does that interact with the intelligent frame creation?
So the intelligent frame creation part of it, that's really the motion vector detection and the motion compensation on this subfield level. So if you use a setting in the menu and you switch intelligent frame creation off, this motion compensation on the subfield level is switched off, but the picture is still built by 12 subfields per frame. So you still have the 600 Hz, but without intelligent frame creation. So the difference between setting IFC, as the short form is, on or off, is not a huge one. It's more a subtle one, which is clearly noticeable in, like, when you look at, for example, tickers running through the screen.
And remember, in a Sanity 202, I also raised the question, why does IFC control appear to do nothing on HG10? So does that answer that?
That does basically answer that, because the switching IFC on or off might not become obvious in every scene, but if you have really critical scenes like fast moving objects which are moving quickly across the screen, then you will notice a difference, but not like if you're watching a news speaker on television. That will not show any difference then.
And moving on, a question from Holly80, and he asks, I'd like to know how Panasonic monitor the performance of their screens over time. Do they keep screens in a lab and monitor their performance in different environments, temperatures, etc.? Is that something that you do?
Yes, we start monitoring, we start testing several weeks before the actual mass production starts. We start with an artificial aging process of the panel and the TV, and we keep on doing that over the whole lifespan of the actual product, and even after. So even if new products replace the previous ones, we still keep on monitoring the previous ones.
Excellent. And the last question comes from Hardeep, and he asks, what are Panasonic doing to improve the power consumption on plasma screens without affecting picture quality? That's question one. And his second question is that the manual states that even though his TV is plugged into the socket on the wall, it will still draw current. So why is that the case?
So the reason for that is that with Freeview service, that is going to actualize and download EPG data or actualizations during the nighttime. For that, the TV must maintain a certain minimal current level. And asking about, talking about power consumption improvements, so the key for us is really to improve the efficiency of the TV. That means maintaining the light output, or even improving the light output by reducing the power consumption. And some of the improvements we did for the 2010 plasma TVs was, for example, we managed to move the electrodes which bring the current across the cells away from the actual cells, so that they don't cover any light that is emitted out of the cell. Or another improvement is that we put the gas with a higher density into the cell. So with the same amount of power, with the same current, you have more collisions, more plasma in the cell, more UV light emitted, which reacts with the phosphor and emits more luminance at the end, without requiring more power.
So, Marcus, thank you very much. It's been great speaking to you, and thank you for your time on the podcast. And come back and join us again for another video very soon here on avforums.tv.